So I'd like to work through problem 20.29. This is obviously chapter 20. So the information we're given here is that the Trial Urban District Assessment, or TUDA, is a government-sponsored study of of student achievement in a large urban school districts. So it gives a reading test score anywhere from 0 to 500, and a score of about 243 is considered basic reading level, and a score of 281 is considered proficient. Scores for the random sample of for a random sample of 1,400 eighth graders in Dallas had a mean of 248 with a standard error of 1.0. So this is our information. So right off the bat, I can make some assumptions. One is that the random sample size is 1,400 eighth graders. So that is a number that's greater than 30. So it's a pretty decent sized sample. However, in our case, we're assuming that we're using T procedures because of the chapter that we're in. So the first question that they ask is, you don't have the 1,400 individual scores, but you use the T procedures, but use of the T procedures is surely safe. So they're making an assumption here that the T procedures is safe. And we know that the T procedures are used typically when we have a sample size less than 30. But so how and why can we make this assumption that it's safe to use the T procedures even though we have a large sample size of 1,400 eighth graders? And the reason is because the higher you go with your sample size, the less relevant the T versus this Z becomes. So really the deviation between, or the difference between the values that you get using either method, the T or the Z procedure or statistic, is irrelevant. So so that's why you can actually use the T statistic as opposed to the Z. However, I would recommend using the Z, but as I said, you can do it either way at this level. If the sample was actually less than 30, then this would the T statistic would actually be almost a requirement at that point because you have such a small sample size. So part B is asking you to give a 99% confidence interval for the mean score of all Dallas eighth graders. And then it gives you a little warning here. So it says, be careful, it's reporting on standard error, not on standard deviation. Now that's important to know because when we talk about confidence intervals, we're talking about the mean being plus or minus the T statistic times S over the square root of N, this is the error here. So that's really important to know because now we know what the standard error is. They gave us the standard error, that's 1.0. So all we need to do now is figure out what is the T statistic at the 99% confidence interval. And to do that, we need our chart, our T chart, or T statistic chart, and we need to know a few more things. We need to know the degree of freedom here. So the degree of freedom, or DF, is equal to the sample size minus 1. Well, in our case, our sample size is 1,400 minus 1, which is 1,399. Now, if we go over to our table over here, we can see that we only go up to 1,000, excuse me. So we're going to have to, we're just going to have to sort of go with the 1,000 here at this point. So our 1,000 gives us, and then we look for the 99% interval here, and we get this number here, 2.581. I believe that was in the 99 percentile. And now the other question is, so this is our T statistic right here. So now we can actually plug this in to our this original formula up here, and I'll just change the color so that we know. So this we're now taking and for part B, we are plugging all of our information in. So this is going to be x bar plus or minus t statistic times the standard error. And I'll just write it as SE because we don't really need to know the formula because they give that to us. They give us the standard error, that is. So our x bar is 248 plus or minus, and now they give us the standard error up here, so that's 1.0, so that's 1. And then the t statistic that we got was 2.581. And so what this is saying is that our confidence interval is actually 248 minus 2.581 and 248 plus 2.581. This should give us 245.42 on the low side. And on the high side, this should give us 250.58. So anywhere within the range of 245.42 and 250.58 is our confidence interval for 99% confidence. So if we were to draw this on a graph, let me just make a little normal curve here. So if we were to draw this on a graph, this 248 would be our mean. And then our confidence interval would be the 245, sorry, 245, and then the 250, we'll say just round up to 251 here. So this is our 99% confidence interval here. So now they're saying in part C, they're saying, well, urban children often perform below the basic level, and they're asking, is there a good evidence that the mean for all Dallas 8th graders is more than the basic level? So we know from the above section here that the basic level is 243 from the text here. So 243, let me use a different color, 243 is probably over here somewhere. So 243 is the basic level, and what we figured out was we're 99% confident that the mean of the scores is going to fall somewhere between 245 and 251. So we can say with a bit of confidence that that they do outperform at the basic level. So they perform above the basic level.